Alright guys, so this is 1.2. 1.2 is all about transformations. So let's dive right in. We're going to start here on the right side. Okay, so transformations guide. So this is kind of like the main bulk of the notes right here. What we have up here, this is called standard notation for transformations. Notice that there's an f of right here. That f of is just telling me that we're taking the function and then we're doing all of these transformations to it, which we're about to talk about what all those things are. Anyway, translations. So h, as you can see, is right here in the equation. I also put it down here. When we have h and it's positive, so h greater than 0, then this is a horizontal transformation, horizontal. Okay, and it's horizontal to the right. Let's put the word, we're going to say shift. This is a horizontal shift to the right if it's positive. If it's negative, so down here when h is less than 0, then it's a horizontal shift to the left. Shift to the left. Okay. Next we have k. Notice that k is right here. It's outside of that parenthesis. So again, when k is positive, these are called our vertical shifts. So this would be a vertical shift. I like to say up or positively. Then when it's negative, this is our vertical shift down. Okay. So those are all of our translations. Translations are physically talking about sliding the point either left, right, up, or down. Dilations, okay, so dilations are a little bit different. So, a times f of x, this is when a is greater than 1, okay, so all of our values greater than 1. This is going to be called a vertical stretch. Okay, notice that our a value is in front of the f, so we're multiplying the function by a. Okay, so this is called a vertical stretch, and then sometimes you'll see it called by a factor of a, so whatever a is. Okay, next we have a when it's between 0 and 1. So what are these? These are fractions less than 1. Okay, so those are our fractions that are less than 1. What does this do? These are called vertical shrinks. Okay, and then again you could say by a factor of a. The reason that it's a shrink is because if you think about it, guys, right, if we take a fraction, we multiply it by a whole number, what's that doing? It's making it smaller, right? So all of our fractions, as long as they're less than 1, are going to shrink our graphs. Okay. Next we have a reflection. So reflections happen when a is a negative number. Okay, so reflections are over the x-axis, the ones that we'll be talking about in this class. So reflection over the x-axis. Okay, and what does that look like? That means we're going from x comma y to x comma negative y, right? So just our y is becoming negative when we have a reflection over the x-axis. So those are kind of all the notes that we need to get through. Let's now take a look at this little box to the left, which we will now go through all of those transformations. So let's take a look at these 3 points. We have 1, 1, so right here, 5, 1, 1, 2, 3, 4, 5, up 1, and then 3, 3. So we're building this little triangle right here. Okay? So, with this, we're going to consider them f of x. So we graphed those points and connected them. Let's do the following transformations to f of x. So this first one is telling us that we want to do, okay, this is a horizontal shift. It's inside the parentheses. We have to keep in mind, what is that to? Well, normally it's f of x minus h, but because it's positive, that means it's minus a negative, okay? So that means our h value is equal to negative 2. This tells us a horizontal shift left. Horizontal shift left 2, okay? Let's change this to a different color, and then we'll represent that on the graph. So I'm going to make it my green, So then if we're taking a horizontal shift left 2, that means we're physically taking all of these points and moving them to the left 2. So it would be here, 1, 2 would put us here, 1, 2 would put us here. So then now our new graph is right here. Okay, so that's a horizontal shift. It's physically just sliding the points to the left 2. If we take a look at this next one, right, well now our h value is a positive 2 because it's back to our normal thing, f minus h. So that means h is positive 2. So this is a horizontal shift to the right. Horizontal shift right 2. Okay? So then if we did that to our original function, now we're going 1, 2 to the right, 1, 2 to the right, 1, 2 to the right, and then we're going to go with this pink graph right here would be everything shifted to the right too. All right, next one. Our next one, okay, now we're outside the parenthesis. Outside means vertical. Our vertical is our k, so this is k is positive 2, so that's a vertical shift up 2. Okay, so then we come here and we take all of our points, 1, 2 up, there's here, 1, 2 up, 1, 2 up. Okay, so now if we draw that, bam, that would be our vertical shift up 2. As we look at the next one, right, this is a negative 2, so then k is equal to negative 2. That's our vertical shift as well because it's outside the parentheses, but this time it's a shift down 2 because it's negative. So we take all these points, we shift them down, and then we draw our graph. Okay, so it's just everything shifted down. All right, next, as we can see here, we have, we'll keep with those colors, 2 on the outside, okay? So it's a whole number, so this is an a value of 2. It's going to be greater than 1, so then this is our vertical stretch by a factor of 2. And what this does, guys, is it says it takes x and y, and then what it does is it makes it x comma 2y. So we're physically just taking the y values and multiplying them by 2. So in this case, our first point that we have is 1 comma 1. Well, then we're going to insert it into this, and it's going to become 1 comma 2. The next point that we have is 5 comma 1. That one would become 5 comma 2. And then our last one is 3 comma 3. That one would become 3 comma 6 if we multiplied the y value by 2. So then let's graph that point. We have 1, 2, we have 5 up 2, and then we have 6. So 3 up 6, so 1, 2, 3, 4, 5, 6 puts us here. So then if you look at this, guys, what happened is we stretched it, we made it look like it's a little bit skinnier, but then we pulled it up taller, okay? So that's kind of what happened. The base stayed the same, right, because the x values didn't change, but then we pulled it up to elongate it. All right, last one. Here we have a value of 1/2. This is going to be our vertical shrink. So vertical shrink. So it does the same thing, guys. This is by a factor of 2, except now we're just going to take our factor of 1/2. And then now we're just going to take all of those values that we have, right, the y values, and it's going to be x comma y goes to x comma 1/2 y. So then literally we just take all of these points and we multiply the y values by 1/2. So we'd go 1, 1/2. We would do 3 and then up 1.5, which would be right there. And then we would do 5 up 1/2. Okay, so that last one would look something like this. Go from here to here, from here to here, and then from here to here. Okay, so it'll look something like that. And I mean, mine is a little bit messy, but that's okay. All right. So that's how we do those kind of transformations. So now let's apply them to things that actually look like graphs a little bit, okay? So when I label it like this, what I'm looking for is for you to label all the values, so A, H, and K, and then explain what they do. So this is the explanation part. So our A value in this case is 1, so then there's no vertical stretch, right? You multiply something by 1, it's not going to change, so we can say not applicable here. Our h value is positive 1, k value is 0. So if there's no k value, that means, again, not applicable. Our h value is 1, so that's going to be, we're going to shift everything to the right by 1. So we shift to the right 1, 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 and then bam, we just connect those dots, and we have our new graph. Okay, so number 2, very similar, right? Okay, number 2 though, this time our k value is -2, h is going to be 0, a is still going to be 1, so the first two in this case are not applicable. The last one tells us that we're going to shift down. Okay, down by 2, 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 and then we just got to connect the dots the same way that they connected them the first time. And bam, we have our graph. Okay, so next one. This says write the equation, then do the transformations to the graph. It says a vertical stretch by a factor of 2 and a horizontal shift left 3. So this is a h, this is a k, right? Shift left tells us it's -h. So when we're writing this, our transformation function is going to have a 2 in the front of it because it's a stretch by 2. And then we put our f of x. Horizontal shift left 3, so that's -h, right? And then there's no k. So if we simplify this, right, it would just be x plus 3 when you write that. So, coming through this, right, vertical stretch by a factor of 2. This is what we have to do first. We have to do the vertical stretch first, and then we do all of our translations afterwards. So we're taking all of these x values and we're multiplying them by 2. So this is -2 here. So then it's going to become -4, right? +3 will become +6. 0 will stay 0. +4 will become +8. So 4, 5, 6, 7, 8. So it just goes off the graph just a little bit. Okay? And then we can do our horizontal shift. So left 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3 puts us right there. Then we graph all of those. And then as you can see, it should look exactly like the original graph, okay? We just stretched it out. We pulled it taller and we shifted it to the left 3. Okay, we elongated it. Sometimes it's helpful if you change these first transformation points and make them a different color. Okay, that way you can tell. But however it works for you guys is the best for sure. So next one, 4. A is 1/2, k is 2, h is 0, so h is not applicable. This is a shrink. This is a shift up. Okay, so now we're taking all of these values, multiplying them by 1/2, so 1, 2, 3, 4, 5, 6 moves us to 1, 2, 3. 1, 2 would move us to 1. 0 stays at 0 if we multiply it. 1, 2, 3, 4 moves to 2. And then 0 stays to 0. Then it tells us to shift everything up 2. So then we're going to go 1, 2 up, 1, 2 up, 1, 2 up, 1, 2, 2. And then we just connect all those dots. So a shrink should make it look like we smushed this thing down just a little bit. And as you can see, the slopes of all those lines are a little bit smaller, so therefore we have smushed it correctly with our shrink. Okay. All right. Next one. Write the equation, then do the transformation of the graph. Reflection over the x-axis. Okay. So we're reflecting only. That doesn't mean we're stretching it at all. So if we're reflecting, physically the only thing we have to do is make it negative f of x. That's the only thing we're changing for a reflection, right? If it was a reflection and a stretch, then it would be negative and then whatever the stretch is, so negative a. But in this case, there is no stretch, so we just say negative. And then what that's going to do is it's going to take our x, y's, and it's going to make them x comma negative y. Okay, so we're just multiplying all the y values by the negative in the front. So then we go 1, 2, 3, 4 is going to become negative 1, 2, 3, 4. Negative positive 2 becomes negative 2. Positive 1 becomes negative 1. And as you can see, we're physically just reflecting this straight over the x-axis. Okay, connect all those dots. and bam. Right there, we have our reflection over the x-axis. So, let's take a look at 6. Taking a look at 6 here, we have -2, so that's a reflect and stretch. Okay, h value is 0, so not applicable, horizontal shift, and then our k is 1, +1, so that's a shift up. Okay, you always have to do the a value transformation first, so it's saying reflect and stretch. So, what that means is we're going to take our xy's, and then they're going to become x comma -2y. So we're physically just taking that a value, multiplying it by the y value. Okay, so as we go through this, guys, we're going to say, +2 here will then become -4. So 1, 2, 3, 4. 0 will stay 0. +3 will become -6. 1, 2, 3, 4, 5, 6. 0 stays 0, and that's +2. So -4 again. Okay, and then our k value says all of those things are going to get shifted up 1. So we go up 1, up 1, up 1, up 1, up 1. And then if we connect the dots, what it should look like is it should look like a flip over the x-axis. Then we stretched it to make it taller, and then we shifted everything up 1. And that looks right? It looks like we pulled this apart this way, right? We pulled it apart. We flipped it over the x, okay? And then we shifted everything up, okay? So, last 2. Write the equation, then do the transformation of the graph. So this is horizontal shift right 1, vertical shift up 2. So that's +2. Horizontal shift to the right 1 means that we're going to have a +1 for the h value. So then it's going to be f of x minus 1, and then +2. So then that physically says we're going right 1 up 2, right 1 up 2, right 1 up 2, right 1 up 2, right 1 up 2. Graph all of those. Should look exactly the same because there's no stretch, just everything is shifted to the right 1 and up 2. Okay? Awesome. So, last one. Vertical stretch by a factor of 3, so that's 3f. Horizontal shift left of 2, h plus 2, because that's a -2 for our h value. And then a shift down 1, so that's -1 is k. So then we have to do our stretch by 3 first, so that's -1 becomes -3. +1 becomes +3. -2 becomes -6, so 3, 4, 5, 6. +2 becomes +6. And 0 will stay 0. Shifting left 2, so 1, 2 to the left, 2 to the left, 2 to the left, 2 to the left, 2 to the left. And then shifting everything down 1. Down 1, down 1, down 1, down 1. Oops, sorry. And then down 1. Okay, so then we connect all these. It goes up first, then it goes down, okay, to here, then it goes up to here, and then back down to here. So as we start adding more transformations, it can start to get a little confusing. So again, using multiple colors is super helpful with these guys. And as you have questions, please feel free to Canvas message me, email me, whatever, okay? But that's transformations. Please try out the homework, and I hope you guys have a great rest of your day.